Hi. Welcome to our video where you will learn how to analyze your model and interpret the statistical analysis results of Consteel. So, let's begin. Let's open the simple haunched frame structure we have created in the basic modeling tutorial. Load cases and load groups are already defined based on the loads tutorial video. We will cover a recommended workflow for analyzing your model. To begin, it's recommended to perform a model check in the Finite Element tab by clicking the Model Check button. This will open the Diagnostics panel on the right side, which displays messages categorized as errors, warnings, or model inconsistencies. We have edited the model before to show how the Diagnostics panel works. In this example, a red warning indicates that the model requires modification. The message points out that multiple supports are located at the same position. By clicking the plus button, you'll see a list of all overlapping supports. You can select any support from the list to easily locate it within the model, or use the delete option to remove unnecessary duplicates. Once the issue is resolved, rerun the model check. If no further messages appear, you can proceed with your design in the Analysis tab. Before starting the calculation, the analysis parameters must be set. The dialog is divided into three main sections. First, the global settings, which apply to the entire model. These include options such as global imperfections, connection stiffness, and the design mode for cold-formed purlins. Third, the dynamic analysis section, where you can perform calculations like free vibration analysis and modal response analysis. Second, and the main focus of this video, is the statistical analysis settings, where you can define parameters specific to the static analysis of the model. The load case group is the first section, where you can check the option to enable elastic analysis for individual load cases. By default, Consteel provides results only for load combinations, but if this checkbox is selected, results can also be viewed by load case. The second part is second-order analysis of buckling mode-based imperfection load cases, where you can choose to display results separately for each imperfection in the selected imperfection group. Let's turn on the elastic analysis for the load cases. If you want, you can use this arrow button to select or deselect specific load cases. For each load case, you can also specify which results you want to obtain. In our example model, we don't have any shell elements, so we can deselect the calculation of forces and stresses on shells. Performing an elastic analysis for the load cases helps us ensure that the model is set up correctly and that the loads have been applied properly. Let's take a look at the first results. In the first drop-down list, we only have the option to view first-order results. In the next list, we can choose from the calculated load cases for which we want to display the results. Alternatively, we can create a user-defined envelope based on the calculated load cases or load combinations. There's also an option to use all load cases, or just select the ones that are relevant to our analysis. In the next drop-down menu, you will see the available results, namely, deformation, combined or separated by each direction, rotation, warping, internal forces, and reactions. In the last drop-down list, you have options for how to view these results, such as finite elements, diagrams, deformation, or color surfaces. Let's return to the analysis parameters and set up the load combinations for the static analysis. We'll choose the elastic analysis type, which uses linear material behavior. Plastic type is recommended if you want to consider plastic hinge behavior due to bending in special cross-sections. We'll select first-order analysis for the ultimate limit state combinations, and also enable it for the serviceability limit state combinations. Using the small arrow icon in the bottom right corner of this section, we can fine-tune the settings, for example, specifying the portion for which second-order and buckling analyses should apply. Here, you can also set the upper limit for relevant buckling eigenvalues. If any load combination sets were saved previously, you can select them here. Otherwise, you can manually select or deselect combinations based on the desired analysis type. Let's keep only two combinations for the analysis, the third ULS and the 24th SLS combination. Both contain symmetric loading, including total snow and permanent loads. With these selected and the settings applied, we can now rerun the analysis. Compared to the previous case, in the second dropdown, load combinations are now grouped separately for the ultimate and serviceability limit states. I'll select the third load combination, which includes symmetric snow and permanent loads. First, I want to view the deformation in the Z direction. To do that, I'll enable the contour surface, which displays the results using a color gradient applied to the structural members, based on the palette shown in the top right corner of the window. By adjusting the slider next to the combination list, you can scale the deformation visually in the graphics view. We can also compare the deformed shape to the original structure to better understand the behavior under load. Next, the Analysis Reports button gives access to all warnings or error messages generated after the calculation, if any. Finally, the last icon on the Analysis tab opens the table of dominant values. This table is view-sensitive, meaning it reflects the current result type. Only the values at the ends of structural members are displayed. Let's now verify the bending moments on the rafters. First, switch the view to line view and scale the diagram to make the results easier to interpret. By hovering over the diagram, you can see the force values at any given position. If you click on a point using the marker option, a marker will be placed, and it will remain visible across all result views where that value is relevant. Let's place markers at the ridge, the end of the beam, and the end of the column at the frame corner. At the bottom of the window, a table will appear once markers are placed. This table shows all relevant values based on the selected analysis type. In addition, the table can display extreme values for each member, as well as a full list of all calculated values. After checking the first-order results for a few manually selected combinations, let's go back to the analysis parameters, enable all combinations, and rerun the analysis. This time, I'll also select second-order and buckling analysis for the ultimate limit states. The first combo box has changed. It now contains, besides first order, also second order and buckling analysis types. For the second order analysis, the components in the drop-down list don't really change, but the results do, because it considers the effects of deformation that can influence the structure, especially slender or flexible structures. For example, let's look now at the diagram. The marked values are slightly larger for the second-order analysis compared to the first-order. Please note that no additional imperfections are applied in our example model. For the buckling analysis, the combo boxes change. In the second drop-down list, you can still select the loads. But in the third drop-down, there is only one type of result available, the calculated eigenvalues. The number of buckling shapes depends on the specified upper limit of relevant buckling eigenvalues and the number of eigenshapes set in the analysis parameters window. One last useful tip: when selecting a combo box, you can hover over it and use the mouse scroll wheel to navigate through the list. That was our guide for analysis calculations in Consteel. Thanks for watching. Click the like button if you would like to watch more similar videos, and don't forget to subscribe.